All right, let's review briefly of the stuff that we talked about. It seems like it's been a couple days since we've gone over this. So this is kind of like part 2 of section 8.4. I gave you a crazy word, a made-up word that actually stands for some different words. Okay, what is it? Spell it for me. S-O-H, that's so, and then C-A-H, which is the ka, and then the T-O-A, which is the toa. All right. Now, what does this stand for? The sine is equal to what? Opposite over hypotenuse. Okay. Then the what? Cosine is equal to the adjacent side over the hypotenuse. And then this means the what? The tangent. I'll write the whole word out. You don't have to write the whole word out. Just use the first 3 letters. Okay, so the tangent is, go ahead and say it now, opposite over adjacent. Okay? We just use the first 3 letters when we talk about the sine, the cosine, and the tangent. Was it your class I looked this up yesterday? No. Must have been the other class. I looked it up because I was wondering where those words come from, and it was it comes from the Latin. The sine, what was the sine? Shoot, I forget exactly what it meant, but the cosine was like the complement of the sine. That's what the co stands for. I forget what the sine is. It's Latin for something anyway. This is the complement of the sine. Tangent means, it's from the Latin again, it means to touch. Now, that doesn't make sense with what's going on right here, but we just talked about circles in my other class. Did I? Nope. Oh, wow, what's all that? Anyway, they're from the Latin words, okay, so that's where they came from. But what does that stuff mean? What in the world does all that mean? Well, let's put some stuff here. Nice little triangle like this. Again, this is just review. We talked about this the other day, but it's been a little while since we've done this. All right, so let's say oh, here's something I didn't talk about. Remember, I called this angle, I could call it whatever letter I want to. I could call it an angle A, B, C, D, X, Y, Z, doesn't matter. But here's something, don't let this mess you up, because people look at this, I've showed people this in the past, and we're like, oh man, I'll never get this. It's just a letter, it's just another letter, but it's not a letter of our alphabet. Alright, it's a letter of the Greek alphabet. And when you start getting into a lot of math and heavy-duty math, they introduce a lot of Greek letters to you. This is one of the first ones. It's probably one of the most famous Greek letters as far as using it for math. And it looks like a 0 with a little swooshy thing through it, okay? And that thing right there is called theta, T-H-E-T-A. But we say theta, not theta, or theta. We say theta. All right, and it's kind of a circle with a little swoosh through it. Sometimes books will make a circle and they'll maybe kind of make it look like that or something. But this is how I draw it when I draw it. Okay, it's theta. What is that? It's just a letter. That's all it is. Don't get creeped out by it. It's just a letter, and it represents an unknown angle.
I have a question.
All right, back to this again. So theta just represents an unknown angle. So whenever you see a theta, that just means an angle I'm trying to solve for, or an angle that I don't know. Is that all right? Okay. I remember last time I called it like angle A, and up here I called this angle B. It means exactly the same thing. Right? It's just, I just want you to introduce it to you so you get comfortable with it, because the higher up you go in math, the more you're going to see this kind of stuff. And they have different Greek letters that represent all kinds of different things in math. But this is the first time you've probably seen one. Actually, it's not the first time you've seen one. You've seen another Greek letter that represents a certain number, exactly right, and that would be pi. Pi is a Greek letter of the alphabet. You know how we write out words with letters and stuff? Well, that's just a regular letter of the Greek alphabet, and that would be pi. So that's not the first one you've seen, but you haven't seen too many of them, have you? All right. Yeah, delta, remember we did slope? Remember that? So yeah, that's another one too. We've done that before. Remember, it kind of looks like a triangle. Remember delta y over delta x, or change in y over change in x? Did I show you guys that this year? Can't remember if I did or not. All right, yeah. So so it's not unfamiliar to you to use some Greek letters of the alphabet. I guess we just run out of our own. We only have 26 to choose from, so I guess they get tired of those and they go to the Greek letters, all right, just to make it stand out a little bit more. Is that all right? Now, we can only use SOHCAHTOA. These are called, let me write this down. These 3 things right here, sine, cosine, tangent, are called our trig functions. So when I refer to our trig functions, we're referring to sine, cosine, and tangent. Okay? So if I asked you to write down the 3 trig functions, you would write that down right there. Okay? Is that okay? All right, so those are our trig functions. You can only use trig functions when you have what type of triangle? I haven't even really said it yet. A right triangle. So that really needs to be right triangle. You can only use this stuff if you have a right triangle. Look at this right here. It's hypotenuse. You can only have a hypotenuse when you have what kind of a triangle? A right triangle. Where is the hypotenuse located on a right triangle? It's opposite the right angle. Now look, Mrs. Bove came to me, and she's, I don't know if it was you guys or the other class or what it was, but the folks that went to the resource room, and apparently you were having a lot of trouble figuring out which one was the hypotenuse. That should not have even been an issue. I was so mad, okay, not at her, but I was mad at the people she had to explain it to, because you tell me, have I not talked about the hypotenuse many, many, many times? Yes, and I've always said it's what? It's the side that's what? Opposite or across from the what? The right angle. Haven't I done this a whole bunch of times? Yeah, absolutely. Do you think that there's any excuse at all for you to have been sitting in my room not knowing where the hypotenuse is? No. So you see where I'm coming from, don't you? All right. You see that I would be very frustrated, right? Wouldn't you be frustrated if you told somebody over and over and over and over again, and then they just said, "Oh, I don't know what you're talking about"? Wouldn't that be frustrating? Yeah, it would. So come on, listen to what I'm saying. And I don't even know. She didn't give me names or anything, but she said there were just some people, and she was going on and on about where the hypotenuse was, and she shouldn't have to do that. All right, you should know where the hypotenuse is. Okay, so that's the hypotenuse. If this is the angle that we're talking about, theta right there, what is this side right here to angle theta? See this up and down one? What is that side to this? It's opposite, right? Because it's across from it. Look, see how it's directly across from it? This side right here doesn't really touch, how should I say this? This side right here doesn't touch the angle, I guess you could say, right? I mean, this angle is not formed by this side. Let's say it that way. Okay, this angle right here is not formed by this side. So that side is the opposite side. Agreed? It's opposite what, though? Angle what? Theta. Everybody say it for me. Theta. Theta. Okay? So this is theta. Now, if this is opposite theta, what is this side down here on the bottom to theta? It's adjacent. Okay? So it's ADJ. It's adjacent to this. All right? Make sense? So, when we learn that SOHCAHTOA, let's tell you what. Without looking. Don't look in your notes. If I said the opposite over the hypotenuse, which trig function is the opposite over the hypotenuse? It's the sine, because it's SOH, right? S-O-H, opposite hypotenuse. What about the opposite over the adjacent? Which trig function is that? Right, it's O-A, T-O-A, tangent. Everybody got that? What about the adjacent over the hypotenuse? It's the cos, C-A-H, right? It's the A-H, adjacent hypotenuse, and the C goes in front of it, right? So the cosine is the adjacent over the hypotenuse. Everybody with me on that? All right. Let's get rid of these words, and let's put some actual numbers in here.
Hey, Mr.
Hey, Kaylee.
Don't shoot me, but what's theta?
What's theta? It's an unknown angle, and instead of calling it angle A or angle B or angle C, it's a Greek letter of the alphabet that we use to represent an angle that we don't know. All right, it's kind of a universal letter, right? It's kind of like an O with a little swooshy thing through it, okay? But it's a Greek letter. It's in the Greek alphabet, and it's theta. I think it's a capital theta. They have capital and lowercase. I believe, if I'm right, I'm not positive, but I think it might be a capital theta. I'm not sure. Anyway, it doesn't matter. That looks like a theta. All right, now watch this. What if I asked you to find the sine of theta? What would you write?
You would write S equals 3 over 5.
It's opposite over hypotenuse, isn't it? Okay, so what is opposite angle theta? 3. What is the hypotenuse? It's 5. So I write what? 3 over 5. So if I ask you for the sine of this particular angle right here, you would just write 3 over 5. I'm not asking you just yet. I will today, okay? But I'm not asking you right now to find the actual angle. Okay, I'm just asking you to find the sine of the angle. That means the opposite side divided by the hypotenuse. You with me? What is the cosine of angle theta? Well, what is it?
Over 5.
It's adjacent over hypotenuse, right? Because cosine is CAH. Remember that? CAH, adjacent over hypotenuse. So adjacent is 4 over hypotenuse, which is 5. So if I ask you to find the cosine of the angle, and they usually do that at the very beginning, like the very beginning of this homework, they'll ask you to find the sine, cosine, tangent of the angle. They'll, on the beginning maybe of the quiz or a test, maybe the first question, I might say, what is the sine of the angle? And all you're doing is finding the ratio. Don't write that as a decimal. You hear me? Don't write it as a decimal. And I think, if I remember right, I think the book actually says write it as a fraction and write it as a decimal. But even though the book or the worksheet is asking you to write it as a decimal, what am I telling you? Don't write it as a decimal, write it as a fraction. Just write it as a fraction. Everybody hear me? Okay, so write it as a fraction. What's the last one? Tangent, right? So the tangent of theta is what over what? Opposite over adjacent, so numbers 3 over 4. That's opposite theta. This is adjacent to theta. You with me on that?
Let's say you do not want it as a decimal.
That's what I just said, yes. I do not want it. Deep breath, deep breath. I do not want it as a decimal. All right. Okay.
So no
Thought I was clear on that. Apparently not. Yeah, that was hilarious.
So no
Okay, so let me show you this. What if, let's do this. Remember I said I didn't want you originally to find the actual angle. I just wanted you to find the sine, cosine, and tangent of it. Let's do this. Why is this stuff useful? Well, I'm glad you asked because this is the answer to that. Let's get rid of all this. I know it's in your notes, but I'll get rid of it up here. What if I asked you to actually find theta, the angle? Find this angle right here. Okay? Well, I'll show you how to do it. What we're going to do, let's do this. Let's pretend we don't know this one. Alright? Now, we know what it is because you just saw it, right? And we've used it. But let's say we don't know what it is. Let's say we only know two sides, and we're trying to find this angle right here. So this is what I do. I look at this angle, and I say, what two sides do I know? I know this side, which is what? Opposite. I know this side, which is hypotenuse. So which trig function uses, listen, which trig function uses opposite and hypotenuse? The sine, right? You see what I'm doing here? So if I didn't know this side right here, and I didn't bother finding it, I got this, which is opposite. I got this, which is hypotenuse. I'm thinking, okay, opposite, hypotenuse. Which trig function uses opposite and hypotenuse? The sine does. Okay, so what am I going to do? I'm going to write down, I keep going to this color, and then I click on something else. So what do? I write the sine of the angle. Don't know the angle, do I? That's what I'm trying to find. Is equal to what?
3 over 5.
3 over 5. All right, so I found the sine of the angle. Not that big of a deal, right? How in the world do I get theta by itself? Well, let's, I'll tell you what, let me pause this, get my calculator ready, because this is where we're going to use a calculator. Okay, here we go. So we know the sine of the angle is 3 over 5. That really doesn't, we're not really finding the angle right now, though, are we? But here's how we do it. I want to get theta by itself. So I got to get rid of the sine. But remember, the sine is not a variable. Okay, we can't divide by the sine. You wouldn't believe how many people try to do this even when I tell them you can't do this. We're not dividing by the sine. What we're doing is we're taking the inverse of the sine. Let me show you a little symbol for inverse. You'll probably, I don't know if you learned this, I don't think you've learned this yet, but in Algebra 2 you'll learn this. Watch, if I have something to the negative first, 4 to the negative first, put it over 1. You're going to learn this in Algebra 1, or Algebra 2. And I don't know, I doubt you learn it in Algebra 1, I'm not sure. But anyway, I'm teaching it to you right now, watch. 4 to the negative first means I do this. I don't want a negative exponent. You ever seen negative exponents before? No. Probably not. So I don't want a negative exponent, but we have a rule in algebra that says this, that we can take this, we can chuck that whole thing to the bottom. But if I chuck the whole thing to the bottom, I have to change that from a negative exponent, what do you think? To a positive exponent. So if I chuck it to the bottom, it's going to be 4 to the what? Positive first. Well, what's left on top? Well, there's actually a 1 left on top. So what do I get? I get 1/4. So I just want to show you this. Don't worry about that too much. I just want to show you this. That something to the negative first means the inverse of that number. Do you hear what I said? It's the inverse of the number. So if I had like 3 over 2, that's supposed to be a 3, to the negative first. What does that mean? That means I take the inverse of this. What's the inverse of 3 over 2? It's 2 over 3. Do you see that? That's taking the inverse. So now watch. All that's said because of this. I don't divide by the sign, but I do take the inverse of the sign. All right? So what I do is taking the inverse of this gets rid of it. So theta equals, but I got to take the inverse of the other side. Now I want to show you this because you're going to see this on your calculator. I want you to know where this comes from. All right? If I take the inverse of this sign, I got to take side, S-I-D-E, I got to take the inverse of this side. This is how we write it. We write sine. Now how did I take the inverse of something? Take it to the what?
Negative.
To the negative first. So I don't divide by the sign, but I do take it to the negative first. That means the inverse of the sign. I'm not really dividing by it because it's not a number. Sine is not a number. It doesn't stand for a number. All right? But I can take the inverse of it. And you're like, well, why in the world would you want to write all that? Because if you look on your calculator, look at sine right here. Look above it. It's a little bit blurry on this calculator because it's, it's on the computer and stuff. But if you look at your calculator, everybody get their calculator out. And you see the sine as one of your buttons. Even if you have a regular TI-30 or scientific calculator, you don't have a graphing calculator, you'll still see this. You'll see a sine, and then you'll see what? Sine to the negative first. You see it? Okay, it's in yellow, it's above. It's not actually on the button, it's above the button right there. So if it's in yellow, what do I have to do? Second function. Very good. Now watch. There's two different ways to do this depending on what calculator you're using. On this calculator, you actually do it just like the way it's written. You hit sine to the negative first. So how do I hit sine to the negative first? Second function, sine. You see it? It puts it right there on the calculator. That's why I wanted to show you about that inverse sine thing. And then what do we put in there? 3 divided by 5. So I put 3 divided by, don't just put the slash for division. Put actual dividing. Okay, division sign. 3 over 5. I close the parentheses. That's exactly what this is, isn't it? What is this going to give us? What are we solving for?
Theta.
Theta. We're finding that angle, right? So watch. For the first time, we'll be able to find this angle right here by putting that into our calculator. So I hit equals, and there it is. It's around. We'll round it to the nearest degree. So, okay. I'll show you. So how many degrees is that? If I round it to the nearest degree, 37 degrees. Okay, so, 37 degrees. So that's kind of cool, isn't it? That we actually found that angle right there. I didn't know any of the other angles except for that being 90. And I was able to find this and get 37 degrees. Now, if you have a regular TI-30, watch, I'll write the buttons down. You would hit 3, actually let's do it like this, 3 divided by 5 and hit equals. And you'll get what, 0.6? Okay.
No, wait,
Alright.
I'm getting ready to get it.
Okay, wait a second. Just let me do this and then I'll look at your particular calculator, okay? Watch. If you have a TI-30, raise your hand if you have a TI-30 or you have a regular normal scientific calculator. Not graphing. Put it down. You're graphing. If you have a regular scientific calculator, non-graphing. Okay, this is what you would do. You'd hit 3 divided by 5, you hit equals, and you get 0.6. Then, guess what you hit? You hit the second function, right? And then you hit the sine button. Alright, and then that should automatically give you that number, 36.89 or whatever it is. Okay? Everybody with me? Now look, Kaylee, I have a feeling that your calculator is not set to degrees. It needs to be set to degrees. If you have a graphing calculator like this, you got to go to mode. Now, I've already preset mine. Alright, do you see that?
Yeah.
If you go to mode, yours probably is darkened it at radian, is my guess. Right, you got to... Yeah, you hit the cursor, little cursor, over to degree, you hit enter, and then it should be on degrees.
Yeah.
Then try it and see if it works. Let me see your calculator.
How do I get out of that?
Hit clear, hit clear. It'll get out of that.
Okay, let me
Okay.
try it one more time.
Now watch. This calculator right here, it looks like a normal scientific calculator. It's not a graphing calculator, but some of the calculators that look like this, you actually do it the way that the graphing calculator does it. You actually hit sine, negative, or second function sine first, then you hit 3 over 5. So it all depends on your calculator. This is a TI-34, okay? It's kind of got 2 lines. You can see what you type in there and that kind of stuff. So it all depends on your calculator. Know how your calculator works. Listen to me. When it's time to take a quiz or a test, Don't borrow somebody else's calculator because you don't know if the calculator you're going to borrow is the same one that you've been practicing on, okay? Make sure that you always have the calculator that you're going to use, all right? Everybody understand that? Okay. So it all depends on what calculator you have is on how you put those numbers in. So on this calculator, let's clear that. Remember what we do? We hit second function, sine, see it gives you that. Then you hit 3 divided by 5, close it, and you hit equals, and there you go. If you have a regular scientific calculator, like a TI-30, that's a very common one, right? You can go to Walmart, get it for like 10 bucks. If you have one of those, you would hit 3 divided by 5 first, right? Hit equals, and then you hit second function sine. Once you do that, it'll give you this exact answer. Who got that on a regular TI-30 or regular scientific? Did you get it? Okay. Make sure you know how to do that. Has everybody been trying? Okay. Make sure you realize how to do that. Now watch this. So we found that angle right there. So this angle right here is 37 degrees, isn't it? Very easily, without any trig at all, how could I find this angle up here? Do what?
90 minus 37.
Just 90 minus 37. Because look, these two add up to 90, don't they? Because this is 90 degrees, right? So these two plus this is 90. So I don't have to go 180 minus 90 minus 37. Because I already know 180 minus 90 is 90. You got that? So all I got to do is go 90 minus 37, which is what? 53? So this angle right here should be what? 53 degrees. Right? Well, you could find this angle using the trig function, but you got to do trig function on one of these, right? You could do the trig function, find this to be 53, take that away from 90 and get 37. Either way, you're going to have to use the trig function. So let's do that actually. Let's put theta in a different spot.
Can theta go anywhere?
Whatever angle that you want to find, that's what theta is. It's just, again, it just represents an unknown angle. All right? All right, so we cleared everything. We'll keep the same sides up here. Let's do this one right here. Let's call this angle theta. Now, we could use another Greek letter, but I don't want to confuse you anymore. Okay, we'll stick with theta. We'll just use that every time. All right? So let's find... I tell you what, let's not use theta. Let's use just angle B. Sometimes they use beta, and beta kind of looks like a B. Why did I put brush? Watch. All right, watch. Sometimes you use beta. Beta is kind of like a weird-looking B. But they always kind of make it go like this. This hangs a little bit. Anyway. We'll just say B. We'll just say B. What's that? Yeah, there is probably a beta on the computer. I'm not going to do that. I'm just going to write it out. Okay. Anyway, we'll just call it B. Is that all right? Looks kind of weird.
Be honest with you?
I'm sure you are always honest with me.
Just use B. Don't go into the whole beta Greek because it confuses me even more.
Okay, I just said I was going to use B. I said it. I said I'm not going to go any further. That's all right. You can look. Your brain is big enough to be able to handle a few little extra tidbits. Okay, so be able to. I say I'm not trying to be rude.
Shut up.
Listen. Shh.
I'm so sick of it.
Okay.
It's not funny. He's getting my nerves.
So we'll call it angle B. Is that all right? Everybody fine with that? So it's angle B. What if I wanted to find angle B? Let's pretend. Let's just pretend I didn't know this was 37. I didn't know this was 53. All right? Let's just start it from scratch again. So what would I do this? I'd find these two sides. What is this 3 to this angle B right here? It's adjacent. What is the 5?
Wouldn't that be adjacent?
It's hypotenuse because it's always opposite the right angle. Technically, it is adjacent to this angle, but it's always the hypotenuse because it's opposite the right angle. Okay, so this is adjacent. This is hypotenuse. Which trig function uses adjacent and hypotenuse? The cosine does, right? All right, so cosine. So let's write it out. The cosine of what? What angle am I working with? Angle what? B. Don't know what it is, do I? So I just call it B. So the cosine of angle B is equal to the adjacent over the hypotenuse. Which one's adjacent? Which one's hypotenuse? So we set it up like this. Now once you get it like this, let's solve for B. Right? Take the inverse of the cosine, but then what do we have to do over here? Take the inverse of the cosine. How do we show the inverse of the cosine? To the negative first. Why do we do that? Because it looks like that on the calculator, right? Okay, so this time we're doing the same thing except we're not using sine. What are we using? We're using the cosine. So let's try it. Second function, what? Cosine. See it? So there's the inverse cosine of 3 divided by 5. And then hit equals. And look at that. 53, just like we thought it should be. Isn't that cool?
Yeah.
So that's 53. So this angle right here, now we know it. And that would be 53 degrees. If this is 53, how do we find this one down here very easily? Just take this away from 90. If you take that away from 90, you get 37 degrees. Isn't that cool? Alright. So that's how you find the angle. You do the inverse cosine when you find the angle. Write that down in your notes somewhere. Right. Say, I only do the inverse cosine when I'm finding the what? Angle. Alright. When I find the angle. If I'm missing the angle, that's when I do the inverse cosine. If you're solving for a missing side, you're not going to do the inverse. You're just going to do straight sine, cosine, or tangent. Let's do one where we actually find one of the missing sides. And I'll try to make it fairly easy for us. Okay, so let's say I actually know an angle right here. Let's just make up a crazy angle. 32 degrees. Alright? So it's not a special triangle, is it? It's not 30, 60, 90, but it is 32 degrees. And let's say and that. Alright? Yep, that'll work good. So here we go. And I want to find x and y. Now look, I only know one side, don't I? I only know this side right here is 7. So I can't do Pythagorean theorem. I can't do 30, 60, 90 because it's not a 30, 60, 90, is it? I mean, it's kind of close. It's 32, but I still can't do that. So what do I have to do? I got to use my trig functions. Let's solve for x first. It doesn't matter which one you solve for, but let's just go in order and solve for x. Now look what we have. I'm trying to solve for x, so I need to use this side. What is this side to this 32 degree? It's opposite. Now what side do we actually know? Hypotenuse. So look what I have. I've got what? Opposite, and I've got hypotenuse. Which trig function uses opposite and hypotenuse? The sine does. You see that? So what do? It's not the sine of theta this time, is it? Because this time I actually... No. You always have to take the sine of an angle, but this time I actually know what the angle is. So it's not the sine of x. You always take the sine of an angle. 32, that's right. Everybody see that? So you always take the sine of a particular angle. So this one we actually know what it is. We didn't know what it was before, right? So we just called it b or theta or a or whatever you want to call it. So the sine of 32 is equal to what over what? Opposite over hypotenuse. So give me some numbers. X over 7. Good. Okay. And now we just do a little math and we solve for x. It's really actually pretty easy. How do I get rid of the 7? The 7 is being divided. So how do we get rid of something that's being divided? I multiply. Well, I multiply. I do the opposite, right? The opposite of dividing is multiplying. So the 7s will cancel out. If I multiply this side by 7, what do I do over here? Multiply that side by 7. So just put the 7 out in front. Right there is what I want to put into my calculator. Because I got x by itself, don't I? X is by itself, I just got to chuck that in my calculator. On this particular calculator, it's pretty easy because we just put it in order. Watch. It's sine, or 7, sorry, then what? Sine, and then 32. You with me on that? And then you just hit enter, and there it is, 3.7. So x is equal to 3.7. So that's one of our answers right there. Isn't that cool? So that's this thing right here. It's 3.7. Now if you wanted to, now listen, if you wanted to, you could do Pythagorean theorem now, couldn't you? To solve for y? But I'm not going to. 3.8? You shouldn't. You should. No, you didn't. Not if you put 7 times the sine of 32, you didn't get 3.8. You don't hit, no. You don't hit 7 and then hit sine. Let me see what calculator you're using. No. Look, you're taking the sine of 32. You got, watch, if you had, I should have said this, if you're using a regular scientific calculator, okay, you don't hit 7 and then sine. Remember, this calculator, you do things in the straight order like this, not on one of those TI 30s. All right. What you do is hit this. This is what you put in on a scientific calculator. This is what I would do. I would hit 32 first. Okay, so do that if you have a scientific calculator. Then I would hit the sign. So what that did, that gave you a decimal number, didn't it? Okay, then you would hit times, all right, and then you'd hit a 7, and then I think you have to hit equals. Yeah, I think you have to hit equals. That'll give you 3.7. It should give you the exact same decimal as what we have right there, doesn't it? Yep. All right. So if you have a regular scientific calculator, TI 30 or something comparable to that, this is what you would do to put it into your calculator. Those are the buttons you punch in. Well, it depends on your calculator. Your calculator might... You did it 7, then sine, then 32? Let me see your calculator. All right, now I'm recording. Let's solve for y, but let's not do it by Pythagorean theorem, even though we could. If you wanted to for fun, if we had some time, and we're running short on time right here, but if we had some time, I would do this in the Pythagorean theorem and find out what y is going to equal. But let's do the trig functions since we're practicing the trig functions. So let's say I want to solve for y. All right? And let's pretend we didn't know this 3.7. Is that all right? Let's just say we're starting from scratch again, and we're trying to solve for y. So here we go. Solve for y. So let's see. We're trying to solve for y. So let's see what this side is. What is this side y right here to this 32 degrees? It's adjacent. So we have adjacent, right? Oops, almost gave it away. And then what is this side 7 that we actually know? It's hypotenuse. So this doesn't stand for Aaron Hamrick. What does it stand for? It stands for adjacent and hypotenuse. What goes before that? Cosine. So we use the cosine to solve for y. Everybody seeing that? All right, so you look to see which letter you're trying to solve for. That's adjacent. Look to see which side you actually know. We know the 7, don't we? And it's hypotenuse, so we write that down. And then you figure out, okay, which trig function are we going to use with adjacent and hypotenuse? Cosine, because it's so what? Ka-toa, C-A-H. Make sense? So watch. It's the cosine of what? Is it the cosine of y? It's 32. You always take the cosine of the angle. 32 degrees. Equals what over what, number-wise? Adjacent over hypotenuse. Y over 7. All right? Look, the algebra is exactly the same, isn't it? Multiply both sides by 7. Right? That 7 cancels out with that. So what are we doing? Just plug that into a calculator, right? You guys love your calculators, don't you? So now we get to use them. 7 cosine. Watch, on this calculator I hit 7, then cosine, then 32. And then hit equals, and it's, we'll say 5.9. Okay? So it's 5.9. And there you go. Look, you just found both sides of this triangle. You would have never been able to do that before today, or before learning the trig functions. All right? Because it wasn't a special triangle. It wasn't a 30, 60, 90. It didn't have those Pythagorean triples, right? It wasn't one of those. You only knew one side to begin with. So look at that. You're able to solve all kinds of stuff. If you wanted to, you could find this angle up here. What would that angle be right there? How would I find it, first of all? Not 32 minus. 90 minus, just 90 minus 32. It wouldn't be 90 plus 32 because that would be bigger than 90. Okay? It's 90 minus 32, which is what? 58? So that would be 58 degrees. Sometimes they'll ask you this. Sometimes they'll say, solve the triangle. When it says solve the triangle, what it means is this. Just find all the missing sides and missing parts. So if it's missing an angle, find that angle. If it's missing a side, even if they don't tell you this is x, still find that missing side. And then they didn't tell you this side, so you got to find that side right there. You with me on that? So sometimes they'll say solve the triangle, which means find all the missing parts. Everybody got it? Okay. All right. Let me give you a worksheet, and then you can do that this weekend. All right?